We're going to work through the next 5 questions on the practice test. Question says, find the quotient and the remainder using long division squared plus 6x plus 14 over x plus 3. We're going to use long division. Dividing by x plus 3 and dividing into x squared plus 6x plus 14. We're going to focus on the first term in each one of these polynomials. We think to ourselves, how many times does x divide into x squared? That's x times. Or you can think, what times x will give me x squared? And that's x. And that's what we write up here. We're going to multiply that x times both x and 3 and write it down below. X times x is x squared. X times 3 is 3x. And the next step in the process is that we subtract. So we're going to change these signs. X squared minus x squared is 0. 6x minus 3x is 3x. And we'll bring down the next term. Now we repeat that process over again. Focus on the first term here and the first term here. X divided into 3x is 3. Or what times x is 3x is 3. We write that 3 up here. 3 times x is 3x. 3 times 3 is 9. We need to subtract, so we'll change these signs. 3x minus 3x is 0. 14 minus 9 is 5. So we get a quotient of x plus 3 and a remainder of 5. On this example, we want to find the quotient and the remainder using long division. We have x to the 4th minus x cubed minus 23x plus 17 over x minus 3. And on this example, I notice that we're missing a term. We have x to the 4th, x to the 3rd. We don't have an x squared. We have an x and a constant term. Now, because of that missing term, we're going to use a placeholder when we write out our division. Let me show you what I mean by a placeholder. We've got x minus 3 divided into x to the 4th minus x cubed. We're going to put a placeholder of 0x squared. 0x squared is the same thing as 0. Minus 23x plus 17. Now the purpose of this placeholder is to make sure all of our like terms line up, and when our like terms line up, we're less likely to make a mistake in combining terms that are not like terms. So we're going to focus on the first term, and the first term in each one of these polynomials. X divided into x to the 4th is x cubed. Or what times x will give you x to the 4th? That's x cubed. We'll multiply x cubed times each one of these. X cubed times x is x to the 4th. X cubed times negative 3, that's negative 3x cubed. You can see that our like terms are lined up. We're going to subtract. Changing the signs. X to the 4th minus x to the 4th is 0. Minus x cubed and plus 3x cubed combine together to be 2x cubed. And we'll bring down the next term, that placeholder that we put in. We'll focus on the first terms again. X divided into 2x cubed is 2x squared plus 2x squared up here. We'll multiply that 2x squared times x. That's 2x cubed. 2x squared times negative 3, negative 6x squared. And we're going to subtract. 2x cubed minus 2x cubed is 0. And 0x squared plus 6x squared is 6x squared. So you can see our like terms are lined up because of our placeholder that we put in. We're going to carry down the next term, minus 23x. So focus on the first terms. X divided into 6x squared is 6x. We'll put a plus 6x up here. 6x times x is 6x squared. 6x times negative 3 is a negative 18x. We're going to subtract, changing the signs. 6x squared minus 6x squared is 0. Negative 23x plus 18x will give us a 5x. Negative 5x. And we'll carry down that next term, plus 17. Focus on the first terms again. X divided into negative 5x is negative 5. Negative 5 times x is negative 5x. Negative 5 times negative 3 is a positive 15. Got to change the signs to subtract. 17 minus 15 is 2. So we have our quotient of x cubed plus 2x squared plus 6x minus 5 with the remainder of 2. So in this next example, we want to factor the greatest common factor out of the polynomial below. We have 35x to the 5th plus 10x cubed plus 15x squared. So on the side here, I'm going to work on finding the greatest common factor of 35, 10, and 15. I'm going to keep a running list on the side here. I notice that all these numbers end in a 5 or a 0, so I know that 5 divides into all of them, making 5 a factor of all of them, a common factor. 5 divides into 35 7 times. 5 divides into 10 2 times. 5 divides into 15 times. And now that I've divided that 5 out, I look at the remaining numbers to see if there's anything left in common. 7, 2, and 3 are all prime numbers. There are no common factors among these numbers. So 5 is the greatest common factor of the number portion. For the variable portion, I have x to the 5th, x to the 3rd, and x squared. The greatest common factor will be the lowest of those powers. It seems a little bit confusing using the word greatest common factor and yet choosing the lowest exponent. But we have to choose the lowest exponent because that's what's in common among all of the terms. So we have a greatest common factor of 5x squared. We're going to factor that out, and what's left inside the parentheses will be 7x cubed. We can double check here by multiplying. 5 times 7 is 35. X squared times x cubed. We add those exponents to get the 5. The next term is 2x. We can double check by multiplying. 5 times 2 is 10. X squared times x is x cubed. And then finally we have 3. 5 times 3 is 15. With the x squared, we have 15x squared. So we factored the greatest common factor out of the polynomial. On this example, we want to solve for x. We have 3x squared equals 5x. And when I solve an equation like this that has a higher power, select all the terms on the same side. I'm going to subtract 5x, and that gives 3x squared minus 5x. I want to collect all the terms on one side because I need a 0 on one side of the equation. At some point in the problem, we're going to use the zero product property, which says if two numbers are multiplied equal to 0, then either A equals 0 or B equals 0. So this is the zero product B. So I moved all the terms to the same side so that I can make sure that I have a 0 on one side of the equation. So when I factor, I'll be able to apply this property. Once I've got all the terms on one side, I'm going to factor the greatest common factor. So for this example, we have 3x squared minus 5x. There are no common factors between 3 and 5, but there is a common factor of x. If I factor out an x, I'll have 3x minus 5 left inside the parentheses. You can double check that you've factored it properly with multiplication. X times 3x is 3x squared. X times 5 is 5x. Once you've got it factored completely, you have two numbers multiplied equal to 0, so one of them must be 0 by that zero product property. X equals 0 or 3x minus 5 equals 0. X equals 0 or x equals 5/3. Solving for x. So we've solved the equation 3x squared equals 5x. We have solutions of 0 and 5/3. On this example, we want to solve the equation p squared equals 10p minus 16. We want to start by collecting all the terms on the same side. That gives p squared minus 10p plus 16 equals 0. We're collecting all the terms on the same side so that we can have that equal 0, and we'll use the zero product property when we're solving at the end. For now, we want to factor. Factor p squared minus 10p plus 16. It's a trinomial and it's going to factor into two binomials. P times p is p squared. I'm looking for factors of 16 that add to negative 10. Fact 16, 1 times 16, 2 times 8, 4 times 4. I can see the 2 times 8 would add up to be a positive 10. How about negative 2 times negative 8 is a positive 16. Negative 2 plus negative 8 is a negative 10. These are the two numbers I was looking for. So my factors are p minus 2 and p minus 8. You can check by multiplying to make sure you factored correctly. P times p is p squared. P times negative 8 is negative 8p. Negative 2 times p is negative 2p. Negative 8p plus negative 2p gives us the right middle term of negative 10p. Then we have negative 2 times negative 8 is a positive 16. This is factored correctly. Once we've factored it correctly, we're going to apply the zero product property. The zero product property says two numbers equal to 0, A must be equal to 0 or B must be equal to 0. So this allows us to take a complicated equation and simplify it into smaller equations. So here we have two numbers multiplied equal to 0. One of these numbers, p minus 2, is equal to 0, or p minus 8 is equal to 0. We'll solve. We're going to add 2. We get p equals 2. We're going to add 8 to get p equals 8. And these are the solutions to my equation. P equals 2, p equals 8. Okay. We can check this by substituting it into the original equation. So we'll substitute into p squared equals 10p minus 16. That's 2 squared equals 10 times 2 minus 16. 2 squared is 4. 10 times 2 is 20. 20 minus 16 is 4. So 2 is a solution to this equation. Let's check 8. 8 squared equals 10 times 8 minus 16. 8 squared is 64. 8 times 10 is 80 minus 16 is 64. So we have two solutions to this equation, 2 and 8. Thank you for checking out my videos. Have a great day.